Let us see the unit 2 in a computer network is in a network layer. So in this unit we are going to learn about IP version 4 addresses and IPv6 addresses and with their respective protocols. The first is a network layer services. The network layer is a TCP IP protocol suite is responsible for the host-to-host delivery of a datagram. It provided a services to the transport layer and receive the services from the network layer. The network layer translates the logical address into a physical address. Then the services provided by the network layers are packet tracing, routing, forwarding, error control, flow control, congestion control, security. So these are the respective operations of an IP version 4 addressing. Next one is the packet switching. Packet switching, the message is split into a small pieces. The packets are transmitted. The data are transmitted in a form of packet. Each packet have the source address and the destination address and the unique sequence number. The packet will trace access the network taking a smallest path. All the packet are reassembled at the receiving end in order to receive. The network layer performance. The network layer performance can be measured in terms of delay, throughput and packet loss. The congestion control is an issue that can be improve the performance. The delay in the sense packet from its source and its destination encounter a delay. A delay in a network can be divided into four types. The four types of delays are a transmission delay, propagation delay, processing delay and queuing delay. Transmission delay in the sense the source host or a router cannot send a packet instantly. If it take an extra time to transmit a data packets, that can be measured using a packet length divided by a transmission rate. Through this, the transmission delay can be calculated. The propagation delay is a time taken between a bit to travel from a point A to a point B in a transmission medium. That is a propagation delay that can be evaluated with the help of the formulas like a distance divided by a propagation speed. Next one is a processing delay. The processing delay is a time required for a router or a destination host to receive a packet from one end to another end. The processing delay may be different from each packets. Next, the queuing delay. Queuing delay can be a normal delay happening between the routers. A router is an input queue connected to each of its input port to store a packet waiting to a processing. That can be evaluated based on the time of a packet waiting in an input and output queues in a router. The total delay can be calculated with the help of the formula n+1 delay transmission plus propagation delay plus transmission rate plus number of delay queues that can be performed. The final answer will be shows the total number of delays for a transmission of data from a source to a destination. The throughput is at any point in a network is defined as a network of bit passing through the point in a seconds. It actually a transmission rate between one source to another destination. Packet loss. During a transmission of data packets, some of the packet get to be lost. That is also be measured in this versions 4 IP address. The congestion control. Congestion in a network layer is related to two issues. One is a throughput and the another one is a delay. And based on the delay, when a load is much less than the capacity of a network, the delay it is minimal. The minimal delay is composed of propagation delay and the propagation delay, both of which are negligible. Based on the throughput, when a load is below the capacity of a network, the throughput increases the probability with the load. We expect the throughput to remain a constant after a load reaches the capacity. The reason of is discompatibility of the packet is because of a data transmission between the source and destination, which will take a more time. So this is a diagrammatic representation of a delay as a function of load, throughput as a function of load. The congestion control mechanisms. When the congestions are become controlling, so that only we will improve the performance. So that can be prevent and removed with the help of open loop congestion control and closed loop congestion control. So these are the two categories of open loop and closed loop. So while transmitting a data packet, the acknowledgement policies get to be improved when a congestion becomes affected. Closed loop congestion control mechanism try to elevate the congestion after it has happened. Several mechanisms has been used to for a different protocols. Back pressure, some of the time the congestion node stop receiving a data from the immediate upstream node because of an pressures being faced while transmitting a data packets. This is a diagrammatic representation. The back pressure is backtracked between the source and destination. The backtrack initiated from the destination back towards the source. The choke packet is a packet sent by a node. This is a kind of packet. This is also be transmitted from one end to another end. This is a diagrammatic representation. The packets are in a form of chokes. Next one is IP version 4 address. It identifies used in IP layers of an TCP IP protocol should to identify the connection of each devices to an internet, which will provide the unique identity of an computer. IP addresses can be a 32-bit addresses uniquely defined with every unique nodes. The IP address notations are being categorized to the binary notation, dotted decimal notation, and then hexadecimal notations. So this is a diagrammatic representation. It can be either represented in a binary format or else in a decimal form. The binary form is a 32-bit address. It can be represented in a dotted decimal notation or else in a 8-bit hexadecimal notations. So this is a diagrammatic representation. The first four totally a 4 partition. The first 2 partition becomes net ID, remaining part be a host ID. IPv4 addresses are classified into 2 address, classful address and classless address. Classful address is a 4 byte 32-bit long that can be categorized into class A, B, C, D and E. Class A address is a 8-bit address. It can be varied from 0 to 7. So this is representation. The first 7 bit is a net ID, remaining 24 bits are a host ID. Class B address, the first 14 bits are a net ID, remaining 16 bits are a host ID. For a class C type, first 21 bits are a net ID, last 8 bits are a host ID. The class D address, the last 28 bits are a host ID. Class C address is a higher order bit of first octet is always set to 1111 and the remaining bits are host IDs, 28 bits. Next one is classless address. Classless address, the whole address space is divided into a variable length block. The prefix in an address defines the block's networks. The suffix of the network is used for a denotion of devices. Next one is dynamic host configuration protocol. This protocol is used to specify the installation and maintenance of a network. Thank you.